Alright, so we've gone over geologic time, we've gone over Earth's history, and now we're going to get into the second part of this workshop on rocks, or the study of rocks known as lithology. This section will also be 5 recordings. So, what is a rock specifically? Well, to understand that, we have to understand what a mineral is. And a mineral is a material that fits all 5 of these criteria. It's naturally occurring, solid and homogeneous, has an ordered atomic arrangement microscopically. It has a definite chemical composition, so you know generally which elements are in it. Within reason, there is some substitution of elements permitted, which we won't go into detail of here. And it's also must be formed generally through inorganic chemical processes. However, there are a few examples of organic minerals out there. So, things like quartz or feldspars would be minerals, and, some of you might look at this and think, well, something like ice is a mineral too because it fits all these criteria, and yes, you're technically correct. Ice is a mineral. So why do we say that? Well, rocks are basically big, solid, consolidated masses made up of several minerals. So if you have a chunk of just one mineral, like a quartz, I think you just call that a mineral. But to have a rock, you have to have 2 or more of these minerals sort of somehow held together strongly to make up and some sort of agglomeration of minerals. So an example here is granite. I won't go and ID all these minerals. You can try if you'd like, but say this pink thing here would be a mineral. This sort of clearish thing here would be a mineral. This black material here would be a mineral. And because you have 3+ minerals held together, that gives you your rock, your granite. So, rocks are identified not just by looking at them by appearance, because many rocks can look like other rocks, and many rocks themselves can vary quite a bit in their appearance, but still be the same type of rock. For example, granites can, be pink in color. They can be more black and white in color. You can't use, say, color, for example, to identify a granite. So the 2 principles we use to identify all our rocks are texture and composition. And these 2 can, in most cases, reliably help you identify your rock. And in these next few recordings, I'm going to show you a bunch of rocks. I'm going to tell you how to ID them, but really, the best way to learn how to identify rocks and learn from those rocks is to go outside or go into a lab and look at a lot of rocks. There's a common saying that the best geologist is the one who has seen the most rocks. So I can tell you a lot about rocks here, but if you really want to learn, you have to go outside and look at some. So in the next recording, I'll leave it off here, and next I will go over igneous rocks.